Okay, today we're doing quadratic functions. The reason it's called a quadratic function is because you got f of x equals x squared. X squared is a polynomial that has a degree of 2, and when you name polynomials with degrees of 2, you get a quadratic. Here is my table for my parent function. If you plug in negative 2, you're going to get a 4, so that's why I have this dot here. When you plug in negative 1, you get a 1, so that's why I have this dot here. 0 squared is 0, 1 squared is 1, 2 squared is 4. So here is my graph. If you notice that the numbers start repeating after 0, so that means this has symmetry. You can see that symmetry on your graph as well after you connect the dots. So I went ahead and put my line of symmetry as x equals 0. Now, if I take my graph and I smush it down to the x-axis, because our domain is x values, then you will see that this graph, when it covers the x values, is from negative infinity to positive infinity. But if I smush it up to the y-axis to look at the y values, then it's only going to smush up to 0 to positive infinity. The vertex is 0, 0. It's a minimum because it's at the bottom. Its interval of increase is from 0 to positive infinity because that's the side of the graph where it's going up. And then it's decreasing from negative infinity until 0. Okay, so now we're going to look at a bunch of others and where we do transformations on these. So I'm going to have you guys get out your notes that looks like this. And our parent function, again, is f of x equals x squared. It's a U-shaped graph. So there's my U-shaped graph. And my parent table, filling these in from the piece of paper I just did a minute ago, we're looking at negative 2. When I square it, it's going to give me 4. Negative 1 gives me 1. 0, 0, 1, 1, and 2, a 4. So those are going to be the parent dots that I'm always going to use. Okay, so the first transformation I'm going to look at is f of x equals negative x squared. When there's a negative in the front, we call this transformation a reflection over the x-axis. Okay, so I'm going to put my 5 parent dots that I had up here. That's 0, 0, the 1s and the 4s. 1, 2, 3, 4. And out 2, that's 1, there's 2. Each one of these dots is going to reflect over the x-axis. So instead of being at positive 4, I'm down here at negative 4. And instead of at positive 1s, I'm at negative 1s. And there is my transform graph. Now, my domain and range do not change, except for, my range does. It's now from 0 to negative infinity. And whereas my interval of increase and decrease, it is flip-flop for my characteristics. Okay. The second transformation, x squared, or f of x equals x squared minus 4. This graph shifts down 4 because of the minus 4. So each one of these parent dots that we had up here, the 1s and the 4s, are now going to shift down 4. So the 4s are going to shift all the way down here to the 0. So that one comes all the way down and this one comes all the way down. The 1s are going to go all the way down to 3. And this 0 is going to shift all the way down to the 4. So my shift is that graph right there. That's shift down 4. Okay, now we're going to look at f of x equals 2x squared. Now remember, each time I'm using x squared, I'm using this table of values over here. So if I take the negative values, that's where I get the green dots. x squared minus 4. I use these values and I subtract 4 every time, and that's where I get these green dots. Same thing here. I can times by 2, and that'll give me my dots over here. But when you have a number greater than 1 in front of your x squared, or in front of your function, it's a stretch by 2, which means it's going to be skinny. So, looking at this, we're going to come over here and we have 0, 0, negative 1, 1, 1, 1, 2, 4, and 2, 4. When I mean by skinny, my green line is going to go in between, my new function is going to go inside this parent function. So stretch by 2 means I come over here and I take 4 and I multiply it by 2. That means I'm going to be way up here at 8 now. On either side. If I know one side, I know the other. 2 times 1 is going to give me 2. So these have gone up here to the 2. 0 times 2 is still 0. So now my green graph, my transformed graph, is inside my new function, my parent function. Now this is a lot skinnier, and yeah, I know it looks like a V, but remember that it's a U shape. It's not pointed, it's got a little bit of curve to it. Think about a piece of paper, and so if I take a sticky right here, and if I curve the sticky, it's still a U-shaped graph, okay? And it doesn't matter how far I squeeze it together, it's still a U-shaped graph until I make it a fold. So that's what I'm talking about, it being a skinny graph. It's still really, really thin, and it looks like it, but it's not. It still has a curve to it, okay? All right, now this bottom one, we're going to do f of x equals 1/4 of x squared. 1/4 is less than 1, and that is a shrink by 1/4, which means this graph is going to be fat. So if I come over here and I go 2, 4, which was our parent, 1, 1, 0, 0, and same thing on this side. Those are my parent dots, remember. My new graph is going to be on the outside. It's going to be a lot fatter than this one I did here. So 1/4 of 4, that's now at 1. Okay, 1/4 of 1, that's going to be at 1/4, which is in between 1 and 0. The same dots on the other side because this graph is symmetrical. I don't worry about the 0 because at this point in time, 0 times anything is 0. And if you notice, the green graph that I just drew is outside my parent function. Now, for these here, my characteristics all stay the same because my graph did not shift up or down. These two up here are going to be the only time that your graph changes characteristics. And only the range changes on this one. Here, the range and the interval of increase and decrease change. So I hope that helps you graphing transformations or doing transformations on quadratics. Good luck with your homework.